Okay, this is course practice 5.3, course practice 5.3, for math. Uh, this is all about areas. Very, very, very easy. Just to explain, because in the CA video, I didn't explain when I really, really don't like it when I don't explain properly. But let's say you have the graph over here. Let's say, I don't know. Okay, just draw it. I don't know why it looks like this. You have your axis, X and Y. And you have, I don't know, let's say a graph, مثلا, let's say, for example, this graph, right? Is I went and I labeled this graph, say, هون 0, هون 1, هون بيكون مثلا 2, هون 3, هون 4, okay? When I told you I want you to find the area between x equals 0 and x equals 1 and the x-axis, intersecting the curve x equals 0, x equals 1, and the x-axis. So if we zoom in a bit, that's going to be over here, in between 0, 1, the x-axis, and the curve. So it would be this shaded region over here, right? Okay, so let's say you, as a person, you're trying to find it. Let's say you gave this to a grade 9, okay? And he's like, shit, man, how I want to find the volume of this, right? So here's what the grade 9 would probably do. He would probably go a bit, zoom out. Okay, here's what he would probably do. He would split this up into rectangles. Okay, very, very small rectangles. So like if you zoom in, can I zoom in even more? I don't think I can. But if he'd make these rectangles as small as possible, okay, and he'd keep on adding these rectangles, because it's a curve, right? So to get rid of that curved part, he would keep on zooming in and zooming in and zooming in and zooming in until he'd get a small, small, small rectangle. Okay, and the difference between these rectangles, we called it delta x. Okay, this is where integration came from. So for every delta x, there's a change also in delta y. And basically, to go against it, he went and said, okay, we keep on adding these areas. So we keep on adding delta x times y plus delta y, and something like this. So like to explain it properly, what he would do is he'd start over here at this rectangle. Let's call it x. It starts at x, and over here, f of x. F of x is the same as y. The area of this rectangle is length times width, so the length f of x times x. And then he would go to the next one and he'd go like, that's another rectangle. Okay, and there's a small part over there. So he would call it x plus delta x, because it's x. He moved to the right by a small bit, multiplied by f of x. Not f of x, sorry, f of x, I don't know, it's called 2. So he would keep on adding these rectangles, and basically he realized there's a pattern, so there's a sum, and this is where they invented the concept of integration, because you know the integral cancels out the delta derivative. Okay, and this is where integration came from. So that's why, I know it's a lot of yap, but that's why whenever we tell you find the area between a curve or any area in general for a curve, we integrate. Okay, this is between the x-axis. And when we get to y-axis, here's one question only. When we get to y-axis, I'll explain what to do for y-axis, but it's generally the same thing. Everywhere it's the same thing. Okay, the area of the region enclosed by x squared minus 5x plus 6 is k over 6. This is when I had the x-axis. Let's say I came and I drew for you a line like this. Heck. Okay? I'll tell you what's the area over here. No, I would want this area, right? This between the curve, the y-axis, and between the curve x equals 0 and the second point of intersection. Let's say you don't know these points of intersection, huh? Between the curve, the x-axis, whatever. I don't know. I'm gonna want this region. Basically, what you do, you'd also integrate, but when you'd integrate, let's call it the first function f of x, you do f of x minus g of x. Okay, this is when you integrate, and of course, you're gonna need bounds. There's always bounds. The bounds for when you're finding the area between two curves, you're supposed to equate the curves. So let's say you have x. Let's see here. Okay, let's just solve this question. I'll suck it up and solve the question. Whoa. Okay, so you have x squared and minus 5x plus 6. You want to find the area between them. The first thing you want to do is find your bounds. To find your bounds, you equate them. So x squared equals minus 5x plus 6. And this is very, very easy to solve. So you move everything to one side. Okay, this came actually in the CA. You can use quadratic formulas. I prefer to factor. Two numbers that multiply to 6 but subtract to get 5 are 6 and 1. Okay, it's a minus, so the plus goes here and the minus goes here. So my two solutions are minus 6 and positive 1. So that means, what are my bounds going to be when I do the integral now? It always, the smallest one is down, the bigger one is up. Okay, you go from smallest to biggest. It goes from small and up to big. Okay, so integral of, remember we have two functions, so f of x minus g of x. So x squared minus, and remember the minus goes into the whole function, so minus 5x plus 6 dx. Okay, yeah, just now you can solve this integral very easily. Distribute the minus, becomes plus 5x minus 6 dx. Integral from minus 6 to 1. Over here now you can just integrate. It's going to become x cubed over 3 plus 5 over 2x squared. I'm going a bit fast with integration because I think at this point everybody knows how to integrate. Minus 6 and 1. Now what do? You just solve it. So you substitute 1, substitute minus 6. So we're going to substitute 1 first. It's going to be 1 cubed over 3 plus 5 over 2 times 1 squared minus 6 times 1 minus, now we open another bracket, minus 6 cubed, remember inside the brackets over 3 plus 5 over 2 minus 6 squared minus 6 times minus 6, close the bracket, close the bracket. Now you take your calculator, where's my calculator? Over here. We're going to go 1 cube, that's just a bit quicker, 1 cube over 3 plus 5 over 2 times 1 squared. I'm not going to write 1 squared, it's just 1. Minus 6, because minus 6 times 1 is minus 6. Now, minus, open bracket. Please don't forget to distribute the negative, okay? It has to be outside the bracket. If you're putting it in a calculator, remember to put it outside the brackets. Don't make this silly mistake. Minus 6 cubed is just going to be minus 216. I don't want to type it out. Okay, over 3 plus 5 over 2 times minus 6 squared, you all know is 36. Okay, minus 6 times minus 6 is also plus 36. Okay, I'm just moving on here. Okay, we equate this and we're going to get minus 343 over 6. And this is the golden step. When you get a negative answer, we take the absolute value of it, which is 343 over 6. Okay, so they said it's k over 6, so this k is 343. Okay, question 2. We'll go a bit quicker with these questions, but yeah. Here we have the curve y equals x minus x squared over 2 between 0 and 3, as shown below. And they want you to find its area. So we have y equals x minus x squared over 2. Please don't make the mistake that I previously did, as the over 2 is only for the x squared. Unless they said x minus x squared over 2, then it would all be over 2. Anyway, so you have this, and we want to find the area, and they gave you the bounds between 0 and 3, so you don't really need to find anything. So this is a very, very simple integral. We're just going to do integral from the bounds are 0 and 3, x minus x squared over 2 dx. To integrate this, it's very easy, but I want to just put some attention to the fact that you can't do it from 0 to 3 directly, because here our graph falls under into the negative side. Okay, for that reason you must integrate from 0 to 2, find it, and then add from 2 to 3. Okay, because you remember, integral from 0 to 3 is the same as doing integral from 0 to 2. Let's just call this f of x dx. Okay, plus integral 2 to 3 dx, f of x dx. Okay, so for that reason you have to split it up. If it's positive, negative, you have to do positive plus the negative. Type, okay, let's continue on the side. Okay, integrate x minus x squared over 2. You're going to get x squared over 2 minus x cubed over 6. You know how to integrate. Our bounds are, we first going to do from 0 to 2, right? So from 0 to 2 plus from 0 to 3. I'll say from 2 to 3. So let's start from 0 to 2. From 0, it's just going to be 0. Okay, remember, sorry, why am I starting with 0? You start with a higher number first. Yeah, for 2, we're going to do 2 squared over 2 minus 2 cubed over 6. Okay, minus 0, right? Okay, plus, I'm going to continue down here. 3 squared over 2 minus 3 cubed over 6 minus open bracket. Now you substitute the 2. 2 squared over 2 minus 2 cubed over 6. Now let's do this in our calculator. Make sure you substitute everything properly, okay? Every minus is distributed. Make sure these are all common mistakes that are very, very silly. Haram. You shouldn't really use it. See, over 2. I don't know why I'm putting over 6. 2 squared over 2 minus 2 cubed over 6. Okay, close the bracket. Oh, close the brackets. Minus 0, we're not going to write it. Plus 3 squared over 2 minus 3 cubed over 6 minus, distribute now, 2 squared over 2 minus 2 cubed over 6. Close your brackets. Whoa, I did something wrong. Oh, sa. This is what I did wrong. Okay. Obviously, if you get 0, you're gonna know something's wrong. Okay? What I did is I immediately added this area to this area. Why this is wrong is because for the first one or the second one of them, you're actually gonna get a negative answer. Right? You're gonna get a negative answer. And then when you add it to the other one, they could cancel out and get you a wrong answer. So for that reason, evaluate the first area and then evaluate the second area. Make sure they're both positive, and then add them both. So let me evaluate the first area first. Okay, this one. See, I think you get 2 over 3. So the first one is positive 2 over 3. Okay, so this one here is 2 over 3, and then we're gonna add the second one. Okay, the second one, I have to retype it. Let me just cut to when it's all typed. So see over here, you get minus 2 over 3. So if you were to add these directly, you're going to get 0. That's the thing. When you have the positive and negative side, this is why, by the way, even if you integrated it, I don't know why I did. And what I did earlier, just adding them directly without seeing which one's positive, which one's negative, that's the same as just integrating from 0 to 3. Because if you integrate from 0 to 3, you're going to get 0. Okay? So you have to make sure each area, if you're doing individual areas one by one, make sure they're both positive before you add them. Okay? So minus 2 over 3, so you're going to get the answer plus 2 over 3. Now, can I add them? Yes. Okay? 2 over 3 plus 2 over 3 is obviously going to be 4 over 3. And they're saying k over 3, so your k will be 4. Okay? Question 3. The region bounded by the x-axis, y equal x cubed over 4 minus 2 x to the power of 3 over 2. I can't really see. But let me rewrite this because it's a bit small. X cubed over 4 minus 2. X to the power of 3 over 2 is the same as just saying square root of x cubed. Whoa, no, not like that. Minus 2 square root x cubed. Or you know what, let me keep it 3 over 2. They probably put it 3 over 2 for a reason. I'll see later. Okay, anyway. Between 0 and 4. They want the area as usual. Okay, so it's all in the negative side. So for that reason, there's no going from positive to negative. For that reason, we can just solve normally from 0 till 4, right? So let's integrate from 0 to 4. X cubed over 4 minus 2 x3 over 2. Oh, they actually gave it. Oh, okay. Yeah, so they saved you. So if they gave it to you as square root of x cubed, you would have to aslan rewrite it as x to the power of 3 over 2. Because when you integrate, you can't leave it as a root. So that's probably why they kept it as 3 over 2. Anyway, let's integrate this. X cubed over 4 would be x4 over 4. No, sorry. x4, sorry. X cubed over 4, when you integrate it, is going to be x cubed over, there was already 4, right? You multiply by, what am I doing? Oh, sorry. X cubed over 4. Let me just take the 1 over 4 to the side. X cubed becomes x4 divided by the new coefficient is over 4. Minus, take the minus 2 to the side. X to the side. Add 1 to the power becomes 5 over 2 divided by 5 over 2. Okay? If there's an over, like if there's a denominator, just take the denominator to the side, take it to the side. It makes your life way easier. Okay, so you're going to get x4 over 16. x4 over 16 minus 2 minus 4 over 5 2 divided by 5 over 2 is actually 4 over 5. Okay, x to the power of 5 over 2. Our bounds are what? Our bounds are from 0 to 4. So we're going to substitute 4 and we're going to substitute 0. Okay, when you substitute 0, you're going to get 0, but let's just substitute 4. So we're going to get 4 to the power 4 over 16 minus 4 over 5, 4 to the power of 5 over 2. This can all be done in a calculator. And then, of course, minus 0. If you have this in written part, please write minus 0 just so that to make sure you get the full mark. Oh, 4 to the power 4 over 16 minus 4 over 5, 4 to the power of 5 over 2. Oh, times. You get minus 48 over 5. Remember, if you see a negative answer, please don't panic, okay? You could have gotten it correct, or you probably got it correct, okay? You have to take the absolute value of it. And it would make sense for it to be negative because, guys, it's below the x-axis, okay? It makes sense, yani. Here, actually, if you don't get a negative, you should be concerned. Or not. Maybe you just put a negative somewhere else. I don't know. But for the most part, if you get a negative answer, don't panic, okay? So 48 over 5, so k will then be 48. Question 4. The area of the region closed by 4x plus 1, the x-axis and the lines x equals minus 1, x equals 2. So this is the nicest question you can see. You have 4x plus 1, 4x squared plus 1, the x-axis and the lines x equals minus 1 and x equals 2. Now, the easiest way people will tell you, and the way probably most teachers would teach this, or any PDF solving these questions, will always, they're going to do this. Integral, minus 1 till 2, 4x squared plus 1, dx. Oh, you're going to get 15. It's no, يعني ما في شك بالموضوع. That's what we say in Arabic. But if you want to learn math properly, and if you want to make sure you don't get any questions wrong, even if you're taking the AP Math next year, if you're taking AS Math, learn. You have to check, does your function ever enter the negative state? Okay? You have to check this. It's sometimes they're going to give you, مثلا, if I told you 4x squared minus 1. This could be negative. So for this reason, you have to check if your function is ever negative. Because let's say, what if it was like this? What if they told you this? So مثلا, like here's negative 1, okay? So they tell you to find this. There would be some negative part, and here's 2. No, 2 2's over here. Let's say 2's over here. So they tell you to find like this and this. So في لعب بالموضوع. So some of it might be negative, some of it might be positive. So for that reason, you need to check, is your function ever negative? That's the first thing you should ever start with, okay? If it's not drawn out for you. 4x squared plus 1, it's very obvious it will never be negative. Use your head. X squared is always positive, and it's being multiplied by 4. And even you're adding 1, okay? If it was minus 1, then it could be negative. If you don't trust me, see, does it ever equal 0? Is there any roots to it? Equals 0, you're going to get 4x squared equals negative 1. X squared is equal to minus 1 over 4. So x is going to be equal to root minus 1 over 4, which is equal to I. Not I, but it's an imaginary number because you can't find a negative root. Or the root of a negative number, sorry. So for that reason, here it's always positive. So now you can start solving. So you have to show 4x squared plus 1 equals 0. X equals root minus 1 over 4. Therefore, it has no roots. No roots. Therefore, it's never negative. Okay? If it's written, you have to show this. You can't just do integral minus 1 to. Anyway, you showed this. Now you know it's always positive. So you know, خلاص, I can integrate normally. All my things are positive. So let me just integrate from my bounds minus 1 to 2. 4x squared plus 1 dx. Let's see. You're going to get 4 over 3x cubed plus x in between my bounds minus 1 and 2. Start your substitution. 4 over 3, 2 cubed plus 2 minus 4 over 3 minus 1 cubed plus minus 1. Yeah, that's pretty much it. Let's put this on our calculator. 4 over 3 2 cube, I'm just going to put it as 8 plus 2 minus 4 over 3 times negative 1, because negative 1 cubed is negative 1, minus 1. Okay, you get 15. So easy. Question 5. The area, this is your first curve. Oh no, it's just one curve. Between the x-axis, the lines x equals 2 and x equals 5. Here is where, Kaman, you have to check, is it ever positive, is it ever negative? To start, we have a negative x squared, so the graph looks like this. So for the most part, it's mostly negative. So we also have to see now, is it ever gonna go up? Okay, and I'm not really, like, it doesn't matter if it's always negative or if it's always positive. We don't care. We don't care about these. The tricky stuff that we care about is this stuff. You see where it's in both sides at the same time. Or مثلا, this stuff. You see? This is the stuff we don't like. Okay? So we need to check. So we need to check, does it ever cross 0? Minus x squared plus 3x minus 2. The easiest way to check, by the way, if you have a quadratic, or I could have done it in the last question, is check if you have b squared minus 4ac if it's positive. Remember, if your discriminant is not positive, if it's negative, then you're not going to have any roots. Okay, let's check this. So 3 squared minus 4 times minus 2 times minus 1. You're going to get 9 minus 8. You get 9 minus 8, right, when you do this, which is 1. So you have a discriminant. Therefore, it's positive. Therefore, you're going to have some positive values and you're going to have negative values. So, I'm not going to try it, but I'll try it at the end. But if you were to integrate now from 2 to 5, the curve directly, you're probably going to get a wrong answer. So, let's try it. Let's try it ourselves and see. Okay? So, we have positive side and we have negative side. Since we have a discriminant. If your discriminant is positive, continue. Okay? Continue. Don't write this positive negative shit. I'm just writing it to show you. Okay? Continue to find those roots, to see when is it negative, when is it positive, okay? Let's see. Since our discriminant is 1, we can just do minus b plus minus root 1 over 2a. This is the quadratic formula, right? So minus b, so minus 3 plus minus 1 over negative 2, because a is negative 1, huh? Okay, so you're going to get, well, let's first do minus 3 plus, so this is going to be minus 2 over minus 2, which is 1, so our first root is 1. How about if it's minus 3 over, minus 3? Ya Allah! This is for the case that it's positive, right? This is the positive case. How about the negative case? It's going to be minus 3 minus 1 over minus 2, which is minus 4 minus 2, which is 2. So you have two roots, 1 and 2. So, yeah, so you have 1 and 2. So the graph, if you want to like look at it, remember the sign for a quadratic, just you don't need to do all of this. I'm just trying to show you. So between 1 and 2, between the roots, it's opposite. The sign is opposite to the quadratic. So if it's between 1 and 2, it's going to be positive. Then after 1 and 2, it's the same sign as the quadratic, negative. Okay? But here, what are they doing? They're saying between 2 and 5. Okay? They could have easily said between 1 and 5. Okay? They could have easily said between 1 and 5. So therefore, you need to know. If it was between 1 and 5, between 1 and 2, it's going to be positive. And then you can continue to evaluate between 2 and 5. Do you get what I'm trying to say? I hope you get what I'm trying to say, really. Well, I'm not trying to confuse you. I don't want to complicate you. For this case, by the way, just integrating it will work. And I don't want you to memorize these cases. I want you to actually solve. Check if it has discriminant, know its roots. 1 and 2. But okay, معناته in between 1 and 2, there's a sign change. And I don't care. Because why? Because they're saying between 2 and 5. Between 2 and 5, you can ignore all of this. But to know that, you need to know the roots. Okay? Please don't memorize. Please. Okay, you can memorize. And hey, what do I gain? I don't gain anything. But at the end of the day, I want you to learn properly. So you get these two roots. You see, it's not 2 and 5 aren't in between 1 and 2. So خلاص, we can just integrate normally from 2 to 5. Minus x squared plus 3x minus 2 dx. Okay? This sign, by the way, it's not needed. You don't need to write all this, wallah. You can just say, oh, the roots are 1 and 2. Damn, 2 and 5. Okay, that's after 1 and 2. So, okay, integrate this. Minus x squared becomes minus x cubed over 3. Plus 3x squared over 2. Minus 2x. And our bounds are 2 and 5. So let's start with 5. Minus 5 cubed over 3 plus 3 times 5 squared over 2. and minus 2 times 5 minus hot to 2 minus 2 cubed over 3 plus 3 times 2 squared over 2 minus 2 times 2. Let's do this now on our calculator. Since it's all one bound, one integral, we don't care about which one's positive, which one's negative. Here we actually have to we have to do the whole thing together. Okay, so minus 5 cubed over 3 plus 3 times 5 squared over 2 minus 2 times 5 minus, open your bracket, minus 2 cubed, which is just minus 8 over 3 plus 3 times 4 because 2 squared is 4 over 2 minus, you get minus 27 over 2, which is the same as 27 over 2 because you take the absolute value. It makes sense to be negative, by the way, because you're below the x-axis. So k is 27. Question 6. The area of the region enclosed by the curve, this, and this is k over 2 square units. What is the value of k? By the way, in the concept, it's showing part below and above the x-axis. So this is why you always need to check. Okay. First thing you check is discriminant. Discriminant is negative, يعني خلاص, you continue. Discriminant is positive, find the roots. Check if the roots fit in with the bounds. If they don't, then you can continue integrating عادي without making any changes to the bounds. But if the root actually fits into your bounds, then or intersects with your bounds, then you have to split it up into two different things. Here, there will be roots that fit in with the bounds. So remember, the first thing you do when you have a quadrat, remember that it might be negative, it might be positive. So you need to know when it's negative, when it's positive. So the first thing you do is find its roots. Okay? Which you can, some calculators, I believe one of the calculators, they have the equation mode function, which is a non-integral calculator, which I strongly advise you to buy. That's very useful, extremely useful, especially if you're doing externals. It saves you a ton of time. Okay? But anyway, if you have equation mode, you can just do it. If you don't, you need to use the quadratic formula. Let's find first our discriminant. This is the first thing you look for. Find the discriminant. So minus 3 squared minus 4 times minus 4, which is 9 plus 16, which is 25. So the discriminant is 25, which is positive, hence it has roots. What does that mean? There is some sign change. So I need to actually continue on to find my roots. How do you find it? Minus b, so minus 3, plus minus root 25 over 2a, so 2 times 1, which is just 2. So you're going to get 3 plus minus 5, because root 25 is 5, over 2. Let's start with the plus. It's going to be 3 plus 5 over 2, which is 4. Let's continue with the minus. 3 minus 5 over 2, which is minus 1. Okay. So, you can now take a look. Minus 1 and 4. We're starting at minus 1, and we're continuing on to 6. So, in between minus 1 and 4, in between the roots, there's a sign. And after the root, it changes sign. So, after this root, it changes its sign. So, that means there is some sign change. Okay? If you want to be professional, if you want to guarantee your mark, you can do the table of sign. It's, in my opinion, and in my exam, I'm going to do this. I'm going to do the table of sign because it's the easiest thing for me. I know how to do it. I practiced enough to know how to do it. We know between the roots, it's opposite to the curve, so it's going to be negative. Before and after, it's going to be positive. Okay? So here you can see we're going to 6, صح? So we have a negative area and we have a positive area. For that reason, what do you have to do? You have to split the integral into minus 1, 4, f of x dx, plus 4 to 6 f of x dx. Please take what I'm saying into consideration. I don't want to confuse you. I want you to learn. Okay? Type. Let's now evaluate it. Okay? Let's find first what's the integral of x squared minus 3x minus 4. It's equal to x cubed over 3 minus 3 over 2x squared minus 4x. What are our bounds? Or no, we're gonna start with what? Minus 1, 4, right? So we're gonna start x cubed over 3 minus 3 over 2 x squared minus, is that 4? That's a 4 minus 4x. In between, أول شيء minus 1 and 4, and we're gonna add. Remember, you need to find the positive value of it, and then add it to. Let's put absolute. Add it to the positive value of from 4 to 6. So x cubed over 3 minus 3 over 2x squared minus 4x in between 4 and 6. Again, absolute value. Okay. If you want to do it all in one step, you can just do it like this. You can throw all of this into a calculator. Okay. Uh, we obviously can't do that, so let me substitute. So we're gonna start with absolute value, just so you can kind of understand. 4 cube. This absolute value doesn't mean anything, just means make it positive. And I'm doing it all in one step. So you can find this, make it positive. Find this, make it positive, then add them. Yes, 4 cube over 3 minus 3 over 2, 4 squared. Minus 4 times 4. Okay. Minus, open your bracket, because remember, you're subtracting both of the bounds. And the subtract, the minus goes into everything. Minus 1 cube over 3, minus 3 over 2, minus 1 squared. Please make sure to put the minus 1 under brackets if it's falling under an exponent, okay? Minus 4 times minus 1. Okay, let's find this first, okay? Just to make our lives easier. Because in the exam, I really don't advise you to throw everything into the calculator in once. Okay, we're gonna go get our calculator. We're gonna do 4 cube over 3 minus 3 over 2, 4 square, minus 4 times 4, now minus into the brackets, minus 1 over 3, because minus 1 cube is the same as minus 1, minus 3 over 2, minus 1 squared is positive 1, and I'm not going to multiply by positive 1, because like there's no point. So this is why in my recordings, I skip over these things, because just so I can save time. But in your exam, please don't skip this, okay? You never know. Okay, make sure to put everything مثل ما هي, copy it into your calculator. But أنا here my recording, I'm trying to save time. Okay, so you're gonna get 125 over 6 for the first one, which I feel like is a bit wrong, but we're gonna see. Next, we have this one here from 6 to 4. So let's put that into our brackets. X cube over 3, so it's gonna be 6 cube over 3 minus 3 over 2, 6 squared, minus 4 times 6, minus open bracket, had a substitute for 4 cube over 3, minus 3 over 2, 4 squared, minus 4 times 4. Let's take our calculator and do it. 6 cube over 3 minus 3 over 2, 6 squared, minus 4, where'd that go? Minus 4 times 6, minus now, open bracket, 4 cube over 3, minus 3 over 2, times 4 square, minus 4 times 4, you get 38 over 3. So over here is 38 over 3. And when we add these, I don't know, for some reason I feel like we're going to get it wrong, but yallah. 38 over 3 and 125 over 6. We get 67 over 2. Okay, so it's not wrong. So you add the both areas, you get 67 over 2. So K is what? 67. Okay. 7. The figure below shows a sketch of the graph of the curve C, given by the equation x cubed minus 10x squared plus 31x minus 30. The area of the region enclosed by the curve C, the x-axis, the lines x equals 2 and x equals 8 is k over 3 square units. What is the value of k? Please realize that, okay, they didn't label the graph, which, okay. If it's not labeled, which I think in the exam they're going to get you labeled, because أول شيء it's a cubic, and they really shouldn't expect you to find the roots of a cubic, which it's very possible, but I don't know. There's no reason. I don't know why you should. If it comes like this, okay, if this question comes like this, it's a cubic, and they tell you between x equals 2 and x equals 8, most likely, these are both roots, okay? If you want to check if something's a root, do synthetic division. You take x cubed, take 2 مثلا, do synthetic division with it. 1 minus 10, 31 minus 30. Take the 1 down, multiply by 2, 2 minus 8. 8 times 2 minus 16. 1 بيطلع لك 15. No. You subtract. So 31 minus. No, sorry, you're adding. What? You add 31 minus 15. And then 2 times 3, 30. Yeah. So that means x equals 2 is a root. And if you want to check 8, let's see. If you take 8, try it as well. You should also get 0 as the remainder just to show that it's a root. So you can get 1 here. 1 times 8, 8, on 2, minus 2, sorry, minus 2 times 8, minus 16, 15. Whoa! What? Did I divide wrong? 1 times 8 minus 10 plus 8 minus 2. Get away for 6. How did I get a root for 2 طيب? Let me try again. 2, 1 minus 10, 31 minus 30. 1 down, 1 times 2, 2 minus 10, minus 8 minus 16. Okay, 15, 30. Okay, that means 8 isn't a root. But well, I'm so lost. Wait. Okay, so I found out. I just got it. The whole point of them giving you one root and the second one not being a root is because they want you to kind of like do it like this. King at home is 8, so they want this shaded area and this shaded area. If you get what I mean. Anyway, since it's not labeled, you can't find out any of this unless you find the roots. Since it's a cubic, you have to try both. We figured out 2 is a root. But please, I just remembered, what am I doing? Why should I use synthetic division to figure out if it's a root? Just substitute 2. When if you get 0, then it's a root. You remember, guys, from grade 10. If something's a root, that means it equals 0 at that point. So 2 cubed, let me just put it, 8 minus 40 plus 62 minus 30. This should get me 0. Yeah, 0. Okay, therefore 2 is a root. Okay, هلا for 8, I told you it's not a root, but let's substitute 8 cubed minus 10 times 8 squared plus 31 times 8 minus 30. You're gonna see it's not 0, but this 90 is actually very useful. It shows that at 8, at x equals 8, y equals 90. So that just eliminates this shaded area. So 8 cannot be anywhere here. Okay? 2 is a root. 8, y equals 90. Wait. It could have this as well. Wait, let me continue. Let's just take this into consideration. You might need it, you might not. But anyway, 2 is a root. But we have here 1, 2, 3 roots. So you need to figure out the other 3 roots. 2 it's not gonna let you solve the question. Well, 2 is a root. How do we find the other 2? You need to know. We did this last year. To find cubics, to find the roots of cubics, you just take the 2 out, right? Take the 2 out. Either by doing long division, you can divide by x minus 2, or you can do synthetic division. I always prefer synthetic division. Okay? Always. Do synthetic division. 1 goes down. 1 times 2, 2 minus 10, 8 minus 8 minus 16, 15, 15, 30, 30, 0. Okay. The degree was 3. Obviously, you're dividing, so the degree is going to go down to 2. So it's going to be x squared minus 8x plus 15. Now, can you find the roots of this? Yes, you can. 2 numbers that multiply to get 15, but when you subtract them, you get 8. You can't do it that way, so we're gonna use quadratic formula. أنا مسطل ولا شو عم بيصير معي اليوم? I don't understand. But anyway, we can use quadratic formula here to solve it. Just not save time. Just to because I can't factor it. I'm trying to factor it. I can't think of it. But anyway, let's use quadratic formula. First, check if there's a discriminant. There's obviously going to be a discriminant since there is more than one. So anyway, solve how much is discriminant going to be? So 64 because 8 squared. 8 squared minus 4 times 1 times 15. So it's going to be 4. So discriminant is 4. So you're going to get the quadratic formula minus b plus minus root 4 over 2. So it's going to be minus 8 plus minus 2 over 2. So it's going to be 8 plus minus 2 over 2. So you're going to get 8. Actually, the positive case is 5 and the negative case is 3. So we now have our roots 2, 3, 5. So you go to your nice graph 2, 3, 5. Okay. And I'm imagining 8 is going to be obviously somewhere over here. Why this part was necessary? Why finding the other roots was necessary? Because what if this was 2 over here? What if this was 2? You know what I mean? You need to know which one's 2. Okay? So 2 is here. obviously 3 is going to be here, and this is going to be 5. And 8 is going to be over here. We need to find all of these areas, okay? So we need this, and we need this. Okay? Let's see. From 2 to 3. So we're going to integrate our sheet from 2 to 3. We're going to integrate from 3 to 5. And then we're going to integrate from 5 to 8. Okay? It's a very long question. I know, I understand. I will completely understand if you're frustrated. And come on, I don't like these types of questions, but they make you think. Anyway, so we're going to start integral from 2 to 3, and then plus integral from 3 to 5, and then integral from 5 to 8. Let's go. I want you the integral of x cubed minus 10x squared plus 31x minus 30. Let's solve it over here. X minus 10x squared plus 31x minus 30. It becomes x4 over 4 minus 10 over 3x cubed plus 31 over 2x squared minus 30x. So, what are our bounds? We're going to do from 2 to 3, from 3 to 2. And then we're going to do plus whatever from 5 to 3, and then plus whatever from 8 to 5. Okay, let's do it. From 3 to 2, I'm going to start over here. Substitute 3. 3 to the power of 4 over 4 minus 10 over 3, 3 to the power of 3 plus 31 over 2, 3 to the power of 2. I'm substituting into our integral, integrated function, minus 30 times 3. Minus, open your bracket, now substitute 2, right? So 2 to the power of 4 over 4 minus 10 over 3, 2 to the power of 3, plus 31 over 2, 2 to the power of 2, minus 30 minus 2. Okay, what do you get? Let's do this on a calculator, and always remember, make your answer positive. 3 to the power of 4 over 4 minus, I'm just going to cut until I substitute everything, okay? So save you time. Okay, so I got 5 over 12. If anybody wants to see how I did it, trying to see, maybe I did something wrong. Times 1 minus 2. Yeah, there's nothing I can see that's wrong. 10 over 3 times 2 cubed plus 31 times 2 squared. Yeah, so that should be correct. We got how much? We got 5. So now let's continue and now substitute from 5 to 3. So from 5 to 3 is going to be 5 to the power of 4 over 4 minus 10 over 3, 5 to the power of 3, plus 31 over 2, 5 to the power of 2, minus 30 times 5. Remember, now minus, open bracket, from 3, right? So 3 to the power of 3 over, sorry, shoot 3 to the power of 3 to the power of 4. 3 to the power of 4 over 4 minus 10 over 3, 3 to the power of 3 plus 31 over 2, 3 to the power of 2 minus 30 times 3. And again, I'm going to cut to when I add this up. Okay, I got 1216 over 9. Let me just check if I did that properly. 10 over 3 times 5 cubed, 31 over 2 times 5 squared minus 35 minus, open bracket, 3 to the power 4 over 4 minus 10 over 3 times 3 to the 3 plus 31 over 2 times 9 minus 30 times 3. So we said 1216 over 9. Okay, next, substitute 8 and 5. Listen, this question, interesting for context, it did not come last year. Okay, in case you want to take some bit of relief, if you want to skip it, I don't know, you do you, wallah, but it didn't come last year. Okay, 8 and 5. So start with 8, 8 to the power 4 over 4 minus 10 over 3, 8 to the power of 3 plus 31 over 2, 8 to the power of 2 minus 30 times 8, right? Okay, minus, open bracket. Now substitute 5, 5 to the power of 4 over 4 minus 10 over 3, 5 to the power of 3 plus 31 over 2, 5 to the power of 3 minus 30 times 5. Okay. And again, we're going to put this on a calculator. So I'll cut until that. Okay, so I got 369 over 4. Now we're supposed to add these, and I hope, ya Rab, it's the correct answer. If it's not, I'm not, not redoing this. See. Oh my god. Ya Allah. Where's that? Oh, okay. I redid this. I don't know how I got 1216 over 9. It's supposed to be 8 over 3. If we add these up now, I hope it's correct. I think I pressed the wrong button when doing the calculator thing. So let me see. Over 3 plus 369 over 4. 286 over 3. So you add these up. 5 over 12 plus 8 over 3 plus 369 over 4. You get 286 over 3. The answer is 286. Question 8. Okay, so here now, this is what I told you about the y-axis. Okay, well, for the y-axis, it's the same thing, except there's just one small step you have to consider. So the area of the region enclosed by the curve y squared equals x minus 8. The y-axis and the lines y equal 1, y equal 3 is k over 3 square units. So here, the important part is the axis you're finding the area with respect to. The y-axis. When we said we're revolving about the x-axis, it's an equation. Y is, I don't know, 5x squared minus 2x plus 3, and we'd integrate it, right? But here's the thing. If it's x-axis, we wrote it in terms of x. If it's y-axis, you have to write it in terms of y. Okay? So you want to have it in terms of y, so there should be y terms. Okay? So basically it means keep x alone. Okay? We need to find an expression for x equals something. Okay? So this is the only thing that's different about the y-axis. The only step is you just have to make x alone. So minus 8 to the side, so you have y squared plus 8. So now you can integrate this. If you have a written part, you can integrate normally from 1 to 3. Your equation y squared plus 8, but you need to write dy. Okay, you have to write dy. You're not allowed to say dx because your variable is y. So we're going to integrate this. Y squared will be y squared, will become y cubed over 3. I'm just integrating, plus 8y. And our variables are, bounds are 1 and 3. So it's going to be 3 cubed over 3 plus 8 times 3 minus open bracket 1 cubed over 3 plus 8 times 1. Okay, let's put this on a calculator. 3 cubed over 3 is 27 over 3 plus 8 times 3 minus open bracket 1 over 3 plus 8. You get 74 over 3. Okay. Question. Oh, I should find the area between the y-axis. Okay, no. See, the thing is, with the area between the y-axis, it can't really be negative. Because, like, if you were going like this, and you're finding this area over here, like this shaded area, like this is how is this going to be negative? You know what I mean? Even if it goes down into negative, it's like how can I say this? Yeah, but it can't really like be negative because like you know what I mean. For y, you don't have to check for roots. Okay. Okay, the area of the region enclosed by the curve x squared minus 6x plus 8 and equals minus x plus 4. We want to find the area between two curves. So what do? We subtract. So we're going to do the integral, but we subtract, right? The first thing though, before subtracting and finding the integral, it's always good to find your bounds first. Okay, find your bounds first by doing y is equal to y. Okay, so x squared minus 6x plus 8 is equal to minus x plus 4. Okay, so you're going to get x squared plus x minus 6x plus 8 minus 4. I just moved everything to the left. So you're going to get x squared minus 5x minus 4. Okay, this is equals 0. Again, we're solving for x because we're trying to find our bounds. So how do you solve this? Which two numbers multiply to get, you have to use quadratic formula. B squared minus 4ac, it's not factorable. So it's going to be minus 5 squared minus 4 times minus 4. So you're going to get 45 is your delta. Okay, so do your quadratic formula, minus b plus minus root 45 over 2. So it's going to be minus 5 plus minus root 45 over 2. So it's going to be 5 plus minus root 45 over 2. Why do I feel like I did this wrong? No, it's correct. It's correct. Let me continue. So let's do this. 5, 3. I'll just do it fast. 1 minus 5 minus 4. So, man, there's something I did wrong. There's something I did. There's no way. There's no way. Yeah, guys, I'm stupid. Um, why did I put -4? I don't know. 8 minus 4. I don't know how I put -4. Should be plus. Let me rewrite this. Oof. Type. Let me find the discriminant. It's b squared minus 4ac. So it's gonna be 25 because -5 squared is 25 minus 4 times 4. So it's gonna be 9. Okay. So you're gonna do the quadratic formula minus b. So minus 5 plus minus root 9 over 2. So you're gonna get. I'm just gonna put it. I'm gonna put it here. انت you solve. Okay, you know how to do this. So you get 2 and 1, 2 and 1, 4 and 1. Actually, let me do it. I shouldn't be late. So you're gonna get 5 plus minus root 9 over 2. So the plus side will be 5 plus 9, which is 40. 5 plus 3, because root 9 is 3. So it's 8 over 2, which is 4. The negative side will be 5 minus 3, 2 over 2, which is, okay, so 4 and 1. So now that you have your bounds, you can actually integrate. Okay, integral from 1 to 4. Remember, you start with your first curve, track the second curve. Okay, dx. Distribute. So it's going to be integral 1 to 4, x squared minus 6x plus 8 plus x minus 4 dx. By the way, what you get after subtracting both curves is actually this. It's always this. It's always what you get when you equate the curves. But do it this way. You need to show you subtracted. Okay. Anyway, so you're gonna get, if you combine like terms, integral 1 to 4, x squared minus 5x plus 4 dx. Integrate, it's gonna be x cubed over 3 minus 5 over 2x squared plus 4x. Our bounds are 1 and 4, right? So let's start with 4. So it's gonna be 4 cubed over 3 minus 5 over 2 4 squared plus 4 times 4 minus open bracket 1 to the 3 open bracket 1 to the power of 3 over 3 minus 5 over 2 1 to the power of 2 plus 4 times 1 close the bracket. When you do it on your calculator, I'll cut to me finishing. After you do this, you get minus 9 over 2, which you obviously need to make positive, so it's going to be 9 over 2. So your answer, K, will be 9. Thank you so much for watching what has been a very long recording, over 52 minutes. It took me long to record it. Thank you so much. Good luck.